Now let us see how to solve this problem. This is a 6-span continuous beam with various loads. On beam number 1 we have a UDL. On beam number 2 you have a UDL in the middle 2 meters, and you have a concentrated load at a distance of 1 meter from node number 2, and you have another concentrated load at a distance of 3 meters from node number 2. And on beam number 3 you have a linearly varying load. The starting value is 0, ending value is 0, middle value minus 60. And on beam number 4 you have another type of linearly varying load. Starting value 0, ending value minus 33. And on beam number 5 you have a concentrated moment anti-clockwise acting at the middle of the beam, that is at a distance of 2 meters from node number 5. On the last beam, that is on beam number 6, we have a trapezoidal load, starting value 20, ending value 40. So these are all the member loads we have. And if you notice on node number 2 we have a 20 kilonewton load, and if you see on node number 4 there is a nodal load of 20 kilonewtons. And now all the beams, as I said, are of span 4 meters. That is, the total X from node number 1 to node number 7 is 24 meters. And all the beams are of 230 by 350 sections. And node number 1 is fixed, something like this. Fixed means it will have Fx, Fy and Mz. This one is fixed. And all other supports, that is from node number 2 to node number 7, they are of simple supports. Simple support means it will have only Fy, that is Fx will be 0 and Mz is 0. So whatever we call simple support, normally in our engineering terminology, instead we call this as fixed but Fx Mz. That means it is fixed but Fx is 0, Mz is 0. Now let us see how to solve this problem. I'll say new project, plane. I'll give problem 2, location is C drive, length units meters and force units kilonewtons. I'll say next and say finish. Now this is the screen that we got initially. We have a grid in isometric view. Let us make this grid straight. Now I have to change this grid basing on the example we have. The problem we have is 6 spans, each span 4 meters. Now I'll say edit here on the right side. Now I'll make these lines 6 over here, and I'll make this spacing as 4 meters. So these are 6 lines, each 4 meters. Now we can see the grid in x-axis got changed. Now I'll say OK. Now we can see this is 24 meters. The spacing between each line is 4 meters. Now we can draw the beam starting from 0, 0. I'm picking with the mouse all these nodes, and once I am through I can say escape from the keyboard, and I can cancel this on the right side, or I can close this grid. Now this is the beam we have. Let me confirm the dimensions. You have the dimension icon here. You pick this one and say display. So once we are satisfied with the dimensions, you may remove them. Say remove, close. Now having finished the geometry, let us give properties. As I said, the property that is the cross section of all the sections, all the members, is 230 by 350. Now I'll go to general and we are in property now. Now I'll say define, and I'll say rectangle, and I'll give 0.35 is the depth and 0.25 is the width. I'll say add and say close. Now when we are in geometry, this appeared like different beams, like 6 beams, but now since the node points are lost, this is appearing like a single beam. How to switch on the node points? Let us see that now. You can right click your mouse and you will get this kind of box, and you pick these labels and switch on this node points, and even you can switch the beam numbers and also node numbers. Now we can say OK. Now we can see that we have 6 members and 7 nodes. These are all the numbers. The one in the middle is a member number, and the one at the node point is a node number. Now let us pick this beam cursor, assign this one to all these members, assign yes. Now let us define supports. For that I'll pick support. I'll say create, because there is no support defined here. We have typically 2 supports, one is fixed and one is simple support. So I'll say create, I'll say add, because the fixed is already highlighted here. You can say fixed is highlighted here. I'll simply say add. Then again I'll say create. Now I'll pick this fixed, but I'll release fx and I'll release mz. When I release fx and mz from the fixity, that means only f5 will be there. I'll say add. Now pick this fixed support and select this node and say assign to selected nodes and say assign yes. Now we got the fixity there. Now pick the simple support, select all these nodes like a window like this and say assign yes. Now once we have given the supports, we need to give the loads. Let me give the load title first. For that I'll go here to load definition. I'll pick this and I'll pick this load cases details, the middle option, and I'll say add, and the title is load case 1. We can retain this and simply say add and say close. Now we got load case 1 here. Now how to add different loads? We have different loads here. On beam number 1 you have a UDL, on beam number 2 you have a partial UDL and 2 concentrated loads. Beam number 3 and 4 you have linearly varying loads. Beam number 5 you have a concentrated moment, and beam number 6 you have a trapezoidal load, and on node number 2 and node number 4 you have 2 nodal loads. So how to give these loads and proceed further, we will see in the next lesson.